Good afternoon, ladies and gentlemen. Welcome to our webinar on AI deep learning for industrial application. Today, we embark on a journey into the transformative world of artificial intelligence and deep learning, exploring their immense potential in revolutionizing the industrial landscape. I'm thrilled to introduce our esteemed speakers who will guide us through the intricacies of real-world application of AI technologies. Let's delve into the future of industrial innovation. Our agenda is structured to provide you with a comprehensive understanding of AI and deep learning principles, introduce you to practical skills for implementation in industrial settings, and equip you to undertake AI projects independently. Without further ado, let's welcome our first speakers. Our first speakers, we have Mr. Arshad Mahmood, a software technical lead at Intel Corporation Malaysia Senjayan Berhad. Mr. Arshad Mahmood brings more than 17 years of experience in AI, robotic, and system software. His contribution to integrating large language model in robotics and enhancing system performance have been highly acclaimed. Mr. Arshad Mahmood will share insight on navigating the latest AI landscape and key takeaways. Please welcome Mr. Arshad Mahmood.
Hello. Hi. Thank you very much. Let me share my screen. Hi. Are you able to see my screen?
Yes.
Okay, good. All right. First of all, thank you very much for inviting me to share some of my thoughts during this wonderful session. And good afternoon, everyone. My name is Arshad Mehmood, and I'm a technical lead in Intel Penang. I'm working with Intel for the last 17 plus years, currently working in robotics, AI, ethics, and enabling GPU technologies on Intel platforms. So today I'm going to discuss or to share actually with you guys something about I recently came across. There was a report being shared recently by the Stanford University department. It's AI Index Report 2024, which actually does does give you the idea about the top trends in different domains for the 2023. The report itself is around 500 plus pages. So I tried to uh, take some of the few domains with their some key takeaways and would like to share with you guys over here. The reason also is very important to go through all those trends. Basically, we should be very much familiar since we are in this field. I'm assuming most of you are already in AI or pursuing your career in AI or very much interested into go into AI. It's very important to keep ourselves up to the pace. What's going on in the industry? What's going on in the academia or in the AI landscape? So I'm gonna share in the next 20 to 30 minutes. I'll try to share some of the key stuff that I got from that report, and I highly encourage this. If you want to go more details, go to that report and get into details about each and all those areas. So the areas I'm going to share is 8 areas. I will be providing some more details into that. First of all, the research and development, technical performance of AI models, responsible AI economy, what impact they have done on the economy or how investments been done in the AI, science and medicine, education, science, sorry, that was a mistake, duplicate, public opinion. And if you want to go to view that report and read it by yourself, here's the link, or you can also do a Google HAI Index Report 2024. It will go send you to that PDF file. Okay. First of all, the first thing that I would like to share from that report over here is research and development. The number one thing that happened in the last 1 year was industry continues to dominate frontier AI research compared to the academia. For example, in from the industry, 51 notable models were released compared to the 15 models from academia, from the education institutes, and 21 models were created with the joint collaboration from academia and with the industry. So, for example, from the industry, GPT-4, and we talk about industry, what models were came from industry, GPT-4, Palm, DAL-E, and from academia, Bloom, OPT, and you heard about Llama. Llama is a joint collaboration between the industry, Meta, and with the academy. Llama, T5, those are the collaboration kind of model that were came. And although there were a lot of other models were also released, hundreds of other models, but here we're talking about the notable models that actually make some stir in the industry. They were kind of were acclaimed of their performance. So these top 50 total were around the one I mentioned over here. Then so the second point was that more and more foundational models came into existence, were released. 149 foundational models were released, more than double release in 2022. So foundational models are basically a large pre-trained model that can be adopted to a wide range of downstream tasks. So when we talk about LLM, what does it mean foundation? First of all, we actually train a model to grasp all the understanding of the data that's been given to them. Then once the model has learned all the understanding, all the links between the text from that large amount of data, then the next step is to fine tune that model for the next step. So here we're talking about the very first step, the foundation. That we saw the trend in 2023, a lot of more and more foundational models were released by the industry and by the academia. Another thing that also was important, that training cost of the frontier models soaring high. It means what it means that as newer and newer models are coming, their training cost is increasing rapidly. For example, the Chat GPT cost around 78 million. The Google Gemini Ultra cost around 191 million. Versus the Llama 2 that was released last year was less than around 20. The actual figure is estimated to be 20 because Meta supposedly didn't release the cost of that Llama training. And why it's increasing? Because the newer models are more complex parameters, more, and that's where when it got more parameters, also the more data is needed to train them. This means it ultimately results in more time to get trained, and also more number of GPUs are required to train that one, and that everything does contribute to increased cost. I give an example that Llama 3 was trained on around 24,500, 24K around NVIDIA H100 GPUs. And if one GPU of that H100 is a special GPU for training these LLMs, costs around 120K to 300K. Cost is around that one, depending on what configuration you get for that PCI card. So if you can multiply this by 24,000 units of that GPU. So that's where the cost getting increased, and in future it will get increased because the model will go for more and more parameters included, which gonna need more time to train. United States leading in releasing top AI models, which were 61, followed by European Union, and then the China was 15 models. Top models were released by the China. And what was the reason why the United States was leading in that? Because there's a huge investment in research and development by the government. Government is taking big initiatives in giving more incentives, more push to the industry to do, and tech giants like OpenAI, Meta, Google, they are all from United States. And another thing is that the United States is having a lot of concentration of the brain mindset. Best mind in the world mostly go towards such US for jobs because of the salary, because of the opportunities. So that's where a lot of concentration of these talented brains are in the US. That's where it actually gives them the advantage to proceed further in more doing excellent work in this LLM thing. Another thing is the 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 economic war between, one is the factor is that between US and China that is kind of going on. That's also another factor because countries are trying to dominate who gonna go and get the best, can lead this AI front. So that's also causing these countries to push or to invest a lot of money into developing AI technology. And also in US, companies have access to the large infrastructure of GPU resources. Just mentioned before that Llama was trained on 24,000 GPUs. Imagine those GPUs, how much CPUs are platforms are required to host those GPUs, and how big cloud center is required. So all that infrastructure is available in US, readily available for everyone to use. Of course, cost is involved, but on top of that, that access is also needed, which is that's why United States is leading. So these are one of some of the few reasons why United States is leading. There will be many more others. Just sharing over here a few. And number of AI patents skyrocketed last year in 2023, China dominating AI patents. Part of the reason was to this, China is actually, was a program, New Generation AI Development Plan was launched by the Chinese government in 2017. It was a comprehensive roadmap, a three-phase roadmap to make China the world leader in AI by 2030. Again, it's all driven by because of the economic war and everything is going on between countries. There's a race going on who can lead this AI technology in future, and that's where Chinese government is very much into having patents. They're actually promoting the patent office in China is very much active in approving patents with a rapid pace. Plus, they are giving very good incentives for companies to file patents over there. But the implication of this whole thing will be that in future, there will be a lot of conflicts coming out, because if the same idea is also filed in US and also in China, which is most likely to be happening in many cases, then there will be conflicts. There will be more restrictions, more kind of on products, and we will be seeing those kind of disputes coming out in future because of that as an implication of those things. And on the right side, you can see the data about number of newly funded AI startups. You can see in US, the most US is leading is 5.5K of startups were initiated in US, followed by China, which was around 1,446, and then goes to other countries by UK. Looks like UK is the third one, then goes with Canada, France, Germany. Israel was also there. Israel was after UK. So this graph, this picture will give you the idea that how those and why again in US most of the startups, because ground over there is very feasible for these new startups, and that's where they encourage, and all those environment is very feasible. Like ecosystem supports all those things, like encouraging companies to open up. So that's where US is on top in this area as well. Next is technical performance. The AI, the first thing that came out from that report was the AI actually beats human on some tasks, but not at all. For example, clearly AI has beaten in humans on tasks that require repetitive stuff, tasks, automation, game playing, the data processing, mathematical and logical computation, all those tasks which need same thing again and again and again. That's where AI was completely outpaced humans on there. But on other areas where like general intelligence and common sense reasoning, IQ, EQ, those creative innovation, emotional intelligence, that's where humans are still being superseding, still on the upfront. Although there is rumors are going on that actually AI has achieved general intelligence, but we still have to see an evidence of that. So overall, in 2023, AI did beat humans in many of the tasks, but many of the things were still humans were in the forefront. The other thing in 2023 happened was the multimodal kind of trend emerged and gets becoming more matured. When what it does it mean multimodal? In previous years, the usually a model, AI model is basically a set of mathematical data that when you provide say, your image or data, it produces some results which a desired result which you are looking for. So usually that model was trained for specific set of input. If it's a classification model for image, only image data can be given. If it's NLP, only the language part is given to that. Only text strings in the form of token are given to. So one model was only able to handle one type of domain or one type of data. So what happens in 2023, a multimodal kind of AI trends emerged, which same model, one model is able to support the video images as well, plus the NLP, the natural language as well. So that is called the multi-model kind of thing. So we have seen Google Gemini is there, GPT-4 is there, and many other examples are there for that trend. Another thing that was observed in 2023 was better benchmarking tests. So what happens? Uh, in previously, the previous set of AIs like ImageNet or other were were kind of basics, were already got saturation because they were created 10, 20, 10, 15 years ago, and on to until a few years back, same set of tests were being used get more matured, there was a need to upgrade those tests to better benchmarking. So that's where the new set of tests, researchers, new, more challenging benchmarking tests, which actually push the limits boundary of the current AI capabilities and give us the true potential, show us the true potential of the state of the art models. It also involved human involvement, those tests to get even more matured output or more quality to assess more quality of the output. Another thing that happened in 2023 was better AI actually resulted in better data, and that data itself resulted in even better AI. As you know, that in order to get a better AI model, you need a good quality data to be on which the model to be trained, right? If you have a good data, if you have a quality data, your model will output quality output, right? And if you give not a quality data, your model will not perform well. So since we started to have a better AI systems, those AI systems were used to generate a better quality inputs, and then those inputs are given back to the AI to even train them even for better quality outputs. For example, if you want training a LLM for some sentiment analysis, you can ask ChatGPT something, generate 5 sentences that express positive sentiment about technology, and then use that. Here is a 5 sentence. You can ask 100 sentences or whatever, and then that sentences are given back to the with that data, with that positive, negative kind of intuition to the LLM for learning. So this was the trend that even the training data was being generated using the AI tools. Then agent-based AI operations were flourishing. What does it mean? That usually when we go to the Google, we search, or even we use ChatGPT or Copilot, we go and put our query and get the results. Now that one of the trend in 2023 was agent-based. Agents are basically a piece of entity of software that you give your query, and that agent goes deeper and try to access multiple models, uh, uh, multiple kind of further entities to get the results, compile the results, and give you a final results. So that is kind of a notion of an agent. So we saw even if you use chat gpt, you can there are a lot of agents, plugins are available which you can try and get the results. Just give the query, sit back, and all behind the searching and everything will be done by that agent, and that then will give you the results. So that kind of trend will also increase during 2023. And another thing that the closed LLM models performing much better than the open models. What is a closed model? Closed LLM models are the one that we are that the model developers haven't released their weights, haven't released their architecture. They're still an IP to them. Number one example is the Chat GPT. Then Copilot is also considered a closed LLM, and open models are the one like llama 3 or t5. Why they are open? Because we know their architecture, we know the weights, we can download them, we can run it locally in our machines, and we, to some extent we can play around with them. But closed models we cannot. But the other side is that models were played performed very well compared to the open model. I think around 30-40% better performing on different set of tasks by the closed model. If you use the output from ChatGPT compared to Llama, which is open source, you can feel the difference. The quality of the output and everything is way higher. Then rewards, because of all these things, reports also becoming flexible with LLM integrations. Models started to emerge like Palm E, RT2, Robotic Transformer 2. What these models basically were designed, for example, Palm E is the multi-model, which actually expects commands from user, and then also some of the vision data, related data from the camera, and then generates commands that are kind of understandable by the robot. And RT2 is an extension of PAMI, which further try to create more domains, more kind of a narrow and more specialized output for robots. So the bottom line is that robots also started to take benefits from LLM integrations. Okay. Responsible AI. This is the third one. Standard to evaluate it's actually what is a responsibility AI. Responsible AI ethics, you can also say, is referred to the ethical design, development, and deployment of artificial intelligence systems to ensure they are aligned with societal values and are safe, fair, and beneficial. One thing was kind of not really encouraging was that the standards to evaluate AI responsible behavior we keep lacking even in 2023. And part of the reason was that since AI, especially the LLMs, those things are considered a black box, and so much rapid, the advancements are happening so much in this LLM that the new models, everything is coming so fast, and the model itself are so huge. The focus of the industry and academia is mostly currently right now towards coming up with new models, coming up more in the industry, especially industry, to create profit, to get revenue, helping in the industry, all those things, and less focus on the responsibility part of the thing, making sure the model is able to generate ethically correct output, not biased output, those kind of things. But there is some work done, like institutes like ISO, IEEE. There is some work. Even I was involved in Intel drafting some of the ISO standards for AI ethics under the display category. We were kind of contributing some of the display related things to the community. Work is going on, but I personally think that the pace of that work is very small compared to the pace where the actual research and AI is evolving the other side. And AI developers quote law on transparency. When here the AI developers means like companies like Meta, Google, ChatGPT, OpenAI, those are considered AI developers. So they didn't release what kind of data they trained or what kind of practices they use internally to train their models. So that's where this was one of the key highlight was in that report that those companies were scored low on the transparency. They didn't release what exactly they uh, they were doing internally. Deepfakes are getting easier to generate and difficult to detect. The number of incidents continue to rise, right? Because it's nowadays very easy to create a deepfake, either video, audio, or image, just because. And no expertise is required. Everybody can do it. A lot of online tools are available, or even locally, you can download model and generate immediately. And that actually doing raising to that thing. More complex vulnerabilities continue to be found in LLMs. The so even in LLM, you can what does it means? That initially last year and previously the hackers could modify the prompt in order to create a response, ethically wrong response from the LLM, or even get some private data that was trained on, and somehow they were able to modify the frame in such a way to get that kind of data, to spit out that data by the LLM output. So those, some of those things were taken care by those ChatGPT and also the Copilot, but still now more and more complex way of those vulnerabilities are emerging, and on the other side, the developers are doing their efforts to tackle them. Growing risks around privacy, data security, reliability. Only few companies mitigated those risks. Again, the risks on their data privacy, security, reliability is continue to grow. Companies are mitigating those risks, but at the moment, again, the focus is mostly on implementing these LLMs, AI, and get the work to generate more output, more beneficial, those things. But on the responsible AI side, the focus is less. Hopefully, in coming years, that will get addressed as we get this technology get more matured. One of the example I'm sharing over ChatGPT is politically biased. When previously, when it happened that people started to get feeling that when they asked about Democrats or the Republicans, the ChatGPT was giving more favorable answers towards was biased, was more favorable answer towards Democrats. And ChatGPT actually came back with the explanation for that. They said that they got the data from web, from different sources, and they never really curated that data. They never really inspect that data, and somehow that data itself was biased towards Democrats. And that's where, when the LLM learned all that knowledge, the output it started to generate, it was also reflecting that input data. What you give, goes in, comes out. This is what it means. And the companies continue to mitigate these kind of things through different means, and hopefully these kind of things will get addressed. Mitigation measures mostly are explicit guidelines, explicit checks are put by these companies. Feedback loops are also there, and research initiatives are also being driven by these developers to make sure that responsible AI is there, is addressed. But again, the pace is slow, not what it should be. Okay. I How much time is there? 36. How much time I have?
5 minutes, Mr. Arshad.
5 minutes.
5 minutes. Yeah.
Okay, I have a few more slides. Actually, I try to go faster over here. Economy-wise, the Gen AI investments are skyrocketing. US saw investment of 67.2 billion in AI, followed by China for 7.7 billion. Fewer AI jobs in the US and across the globe. The AI is why the fewer AI jobs? Because companies are still trying to assess and still kind of, this was last year, and I did see some rise in the AI jobs starting in 2024, and recently I can see a lot of new jobs related to AI is coming up, but this report was 2023. AI is driving significant business efficiency gains, keep decreasing costs and increasing revenue. The organization continued to adopt AI with 55% in 2023, 50% in 2022, and in 2000, just to give you a perspective, 2017 it was 20% only. China is leading the industrial robotic installation. Means most of the factories in China are equipped with the robotics. In 2013, it was 20.8% of the global total. That in 2022, it became 52.4 of the total global total. And data does show that AI making workers more productive and leading to higher quality work. And on the right side, there's a chart that actually gives you the investment by AI geographic areas. In the United States is on the top, and China is way behind. And the other United UK, Israel, Canada, they are even lesser than that. Science and medicine, artificial AI is actually revolutionizing scientific research, enabling scientists to tackle complex problems, accelerate discoveries. For example, how it's actually helping, it's accelerated research and discovery, like data analysis and patterns. The speed of I was reading some of the drug discovery, the medicine discovery was done through AI, and some of the EV battery new materials were identified using the AI, because initially there was around 30 million something kind of formations were there discovered, and then used the help of this AI, 32 or 24 those things. Oh yeah, they came up with 32 million candidates material, right? And then with the help of AI, just 23 promising options were identified, and they were actually made and tested, and then from that, one or two were selected. So that's how AI is helping to proceed, or to actually bring science to the next level, including medicine. A lot of medical devices have been invented with the AI involved in that. FDA have approved more and more. FDA is a regulatory authority in US, which has approved more and more AI-related medical devices. So we're gonna continue to see these trends even 24 and move 25. Education, in the field of education, CS bachelor's intakes grow significantly, whereas masters in CS intakes stays away the same. PhD grows modest. The part of the reason could be why bachelor increase, because since the technology just came with the last 2-3 years, because of ChatGPT, a lot of that kind of thing were there. The fresh graduates of people, the students, they tend to go more, take more into enrollment into the bachelor's for the CS. That could be a reason. Brain drain from academia to industry. More AI PhDs joining industry compared to the past. Why? Because the more money over there, more opportunity, more access to the resources. That's where, and this AI training does require a lot of resources. So that's why the AI PhDs find more suitable to join the industry, to get more involved in that in kind of invention. Lesser movement from industry AI talent to academia. Of course, if going the other side, then from industry to academia was lesser in 2023. Less international graduates in AI from US compared to past years. Part of the reason was because now these AI related courses are being offered all over the world. Next, secondly, visa, immigration policies. Also, there's a lot of online courses that are available nowadays. So it tends to use, students are tend to use more on doing this online rather than going in person. AI-related degree programs are on the rise internationally. Overall, all over the world, they are getting more and more. Those courses are the United Kingdom and Germany lead in European for informatics, CSCE, and IT graduate productions. Right. I have only last two slides. Yes. Policy and governance. Regulated related to AI increases in US. For example, they were related to managing race, safety concerns, safety and security, consumer protection. Like, for example, for bias, discrimination, privacy, and more. So those kind of legislation and those kind of laws were passed in order to prevent or protect customer privacy, and to not to go for a discrimination, because this AI is just a machine, right? So those kind of laws being passed, and policymakers across the globe cannot stop talking about AI. They have actually understanding AI. More and more awareness is there all over the world by the people, the policymakers, and they are actually coming up with those rules to promote innovation in their country. Those kind of laws being passed. And there's a global competition is going on, as I highlighted in earlier. US between, for example, one of the prime example is US and China. So that's where the governments are very much involved in promoting AI because of those things. AI itself is being used in drafting policy making for a more comprehensive, faster, and a rigorous approach. And if you look at the chart over here, it does show how the US being the very high in passing legislation of bills related to AI compared to other part of the world, is leading over here. So this chart is just give you a very high level overview, which country is more actively involving at the government level. Now, the last one is, my last slide is public opinion, which is very, very important. Peoples across the globe are more cognizant of AI potential and more nervous as well. The AI sentiment in Western nations continue to be low, but it's slowly improving. For example, 15% of Americans are excited versus 38% are concerned. But over the time, when they will start seeing the benefits of AI, uh, hope is that that sentiment will continue to grow. The public is pessimistic about AI's economic impact. Number one concern is the job loss, which I think could be the number one thing in everyone's mind. But some people give this example, compare this with the industrial revolution that came in 1950s, that where many people thought that because of the industry, the jobs will lost, but we saw that a lot of new jobs came up, and a whole lot of new set of things. So here is also the job categories are changing. The job it's not they're diminishing. The number one thing is we need to equip ourselves with the changing climate, and want to equip our should equip ourselves with the growing needs of how AI is transforming all that landscape of the job industry on the job side of the thing. Chat GPT is widely used and not widely known and widely used. Everybody is aware of that one, because that's the one where all this thrill has started really, really manifold. And the graph here is people's opinion about AI will change how you do your current job in the next 5 years. So 51% said likely, don't know 8%, and 35% says not likely. And AI will replace your current job in the next 5 years. That's where the 36% says yes, 56% says no, and 8% don't know. And so this kind of again, this was my last slide. And sorry I took over time, but my suggestion would be, if you want to know more details and want to go more into different, go and read that report. Really, really, it will help you to understand where's everything, all that things are going on, and it will help you to grasp the overall landscape of AI in the last 1 year, and also will help you to project what gonna come next in next 1 2 years. So I think that's all from me. Thank you very much for listening. I hope that was beneficial. I'm done.
Thank you, Mr. Arshad, for your enlightening session on navigating the latest AI landscape.
Thank
So
you.
moving on to our second speaker, Dr. Muhammad Imran. This Dr. Muhammad Imran Sarwar is an Industry 4.0 evangelist with more than 18 years of experience in digital transformation. He is the CEO of Datalytica Berhad, specializing in smart manufacturing, smart city, and supply chain and construction 4.0. Dr. Imran is also an HR associate professor at TRB Highcom University and actively contributes to the IEE and SEM communities. Dr. Imran will unravel the mysteries of AI deep learning application and essential skills pathways, paving the way for our exploration into the heart of AI potential. Please welcome Dr. Imran.
Thank you very much, Ms. Sarwar. I hope everyone can see my screen.
Yes, Doctor.
Thank you. I would like to extend my sincere thanks to Mr. Arshad as well as Mr. Afsal for the alignment. So where Mr. Arshad stopped, I will be starting from way forward into how AI deep learning applications are changing, especially in the industry manufacturing, and also what are the essential skills and pathways required. So, if you look into the broader picture of artificial intelligence, so artificial intelligence are basically having a lot of different dimensions, and those dimensions are for specific areas. For example, we have an autonomous vehicle of Tesla that is using advanced driver assistance system, which is AI system, and computer vision for autonomous vehicles. We have chatbots, virtual agents, and even voice bot having those conversational ability stating from AI. We have speech recognition and also knowledge representation. So artificial intelligence, which started small after the Alan Turing test post World War II, have changes our way of life, how we are basically moving into digital transformation and AI transformation, which is happening across many sectors. Uh, so the focus group for this webinar is on deep learning, how deep learning is changing the way we are operating. So this is a bigger picture where we have machine learning, which is using structural data for predictions and also for forecasting. We have a computer vision system, which is using for image classification, facial recognition, and also we have expert system. So expert systems are basically those systems that are assisting medical experts or industrial experts in making decisions by recommendation. Robotics are right now quite common. Even in Malaysia, if you go to the Nasi Kandar, you will able to see that the robots are doing surveying. So that robot are using machine learning to learn about the path, having a computer vision to navigate its way to your table to serve you, and also having an autonomous vehicle capability that they are not being controlled. Deep learning is one of the most advanced artificial intelligence classification that are looking into different aspects of things that we will be studying. The most commons are transformer, GAN, RNN, CNN, and quite recently we have LLM. Our previous webinar, which was in March, and also we were honored to have Mr. Arshad with us and Dr. Shafiq from Bahrain. We discussed about what LLM is doing, why it is here, where it is being used, and what are the advantages. So this deep learning webinar today is even extending the technicalities, little more technicalities in terms of technology and the required skills that would like to have. So the most common scenario right now using artificial intelligence deep learning is your deep learning camera, which is IoT enabled, can classify different shapes, can do the image segmentation, can do object detection, sentiment analysis, also OCR for facial recognition and number plate recognition. So OCR is basically for your data or those numbers or alphabet convert into digital form. Most common is AI cameras to do facial number plate recognition. Right now in Malaysia, when you enter into most of the shopping mall in Kuala Lumpur, so you don't need to do touch and go or other things. They have a number plate recognition that can able to check your number plate and register you. Uh, it has been widely used in other countries for tolls and even for petrol stations. So it is also part, and then anomaly detection. These things are old now. We have implemented this couple of years ago, and just like Mr. Arshad mentioned, now it's more on behavior analytics and even large language models. So in Industry 4.0, when we go deep into deep learning use cases, so there are many use cases that we can able to use for more advanced aspect of monetization. So what is monetization? Monetization is you have a problem, you implement AI based solution, and then there's an advantage. That advantage is usually measured in the form of ROI, and that ROI is quantitative data in terms of percentage, that how many percentage you get advantage. And ROI means based on those percentage, it will take how many months to do the break even of the investment that you have done in the first place. So when we are talking about Industry 4.0, whether it's automotive or manufacturing or supply chain, we have seen that there are a lot of benefits of implementation. Deep learning, which is characterized as DL here, can dynamically optimize your warehouse facility. So it can use with a combination of IoT that is producing the data, and then that data is sent to the cloud. That data can be sent to the cloud either by Ethernet or wireless network, and wireless network are being categorized in terms of low bandwidth, long range or short range, high bandwidth, either long range or short range. So once the data is being ingested in the cloud, you have artificial intelligence based automated system to store the data, clean the data, analyze the data, and make a decisions out of it. So enhancement of assembly line performance is one another use case where your machines are being optimized to have a better end-to-end process. It can improve the generative design aspect of implementation. It can able to have a machine self-optimize for the parameters used by DL. So machine learning was only for prediction and forecasting, but for decisions, deep learning is more accuracy. So in general, deep learning is basically a branch of machine learning, which is quite advanced, use neural network, artificial neural network, and based on influx of data that we have, either structured or unstructured, the machine learning and deep learning models are having an ability to do advanced mimicry of human decision making. Deep learning is also being used in the system to reduce the error occurrences, predict the future demand, and also for quality of service. What do I mean in that? For example, you have a production line and there's a camera. So you are manufacturing goods. So the defect or anomaly in that manufactured good that can be skipped by naked eye can be optimized and catched by the deep learning and also prediction of that. Let's go more deeper into manufacturing. So in general, there are different Industry 4.0 or 4 IR technologies that are working together in AI based models application to Industry 4.0 and its sustainability. And deep learning is one of them. So AI is faster classification, then they have a machine learning, and machine learning is having deep learning. So you can have an autonomous robot using deep learning. You have a IoT infrastructure to understand the energy consumption, inventory management, lead time reduction, and operator safety using deep learning. You can have a system integration of different technologies, and using AI, it can able to have a reduced waste, which is Lean Six Sigma, and also defects reduction. And then you have a stimulated or simulated environment, which can be simulation or emulation to do the predictive maintenance, monitoring, even before you implement, and also additive manufacturing. The additive manufacturing is 3D printing that can reduce the waste, mass customization. So 3D printer can print anything that you can imagine. There are 3D printers can do plastic based manufacturing or even steel by using steel powder as a material and laser to manufacture the steel or iron or copper based manufacturing. So you can able to implement everything, and AI can able to use to further customize on that. So in if you go more deeper, so you have a manufacturing process, production line, and then you are getting the data out of for those process. So there are people are part of process use technology produces the data. Those data come from sensors, from design factor parameters, and also product quality. And you are storing those data. So, as a part of a data governance, you have a different stakeholder in the cloud or server. You have a data lake for the raw data. You have data warehouse for semi-refined data, and you have a data mart for fully refined data. And then from there, you can able to have historical data or real-time data where artificial intelligence, machine learning, or deep learning models are working to do model predictions and decisions. Okay. And then this cycle is coming back because from these decisions, you are controlling your process, production process, or design process, and manufacturing process. Let's go more deeper into this. There are some challenges. We need to acknowledge that building an artificial intelligence system is not easy. Firstly, you need to have a vision and strategy. Second one, you need to have a skills. Need to have affordability, time, business model. So before we deep dive even further, what are those challenges that you need to consider in an organization, especially manufacturing, for the adoption of AI, machine learning, or deep learning? Number one is your business model, whether you have an agile business model in align with digital transformation, whether you have a flexibility in terms of organization structure, because there are new jobs, new roles, and there's a upskilling, reskilling, where you need to learn, unlearn, and relearn. And whether your management, your top management have that vision of understanding the AI landscape and its benefit for your business, and what is the roadmap for that. So, based on what I have experienced so far with MNC GLC in Malaysia, Thailand, the Philippines, Singapore, Indonesia, this part of the world, and also in Middle East and Western places, there are common problems. Like if you would like to harvest the data in terms of TNA, which is training need analysis, or understanding the competency of the leadership or middle management, some says that they know much things, but they don't know. Some say they don't know, but they don't know quite much. So we cannot able to have a full reliability of questionnaire surveys. We need to even have to have a focus group discussion in terms of mapping what they have discussed and what they have input. So the first thing is business model that require digital leadership, having an awareness in terms of IR 4.0 technologies, and also agile implementation and culture, followed by design thinking in terms of innovation. You have a problem, you have a technology, but if you cannot innovate, then there is no sustainability out of it. The second, to me, is the most important is the skills. Whether you understand your competency in terms of skills, and then you have a resources. Do you have a proper training roadmap? Whether you have an alliance with universities, research institutes, or company like us, whether you have a collaboration in terms of experts. So that requires customization and personalization. Uh, I mentioned about customization is easy, means you are not proposing the contents of the training. You are brainstorming with the client what type of content they need. Further personalization. What is personalization? That industry or client or needs to bring a problem that needs to be learned, solved during the training programs. So it's a training and consultancy. So when you go back after having a training, you can bring back the mini project that you have developed in align with your team deliverables, and then you can scale in an agile incremental matter later in this regard. Okay. Next is on the affordability. What are your constraints in terms of business model, revenue stream, and research? And what are the time constraints and infrastructure level? Do you have that proper infrastructure? If you don't have, no problem. If you don't have an IoT, without IoT even, you can able to have a small POC with AI, machine learning, and deep learning based POC. So that requires laptop and some other resources. And at the end, what are the data security in terms of encryption, in terms of algorithm selection, the compliance for standardization of end-to-end security, confidentiality, and also access control. Now, let's go more deeper into manufacturing ecosystem, having a bird's eye view, so we can able to have multiple layer to understand and connect the dots. So the dot connecting will be how the data is being created, transformed, given to the AI black box. Mr. Arshad just now mentioned about AI deep learning based application as a black box. So it has an input as a data, that needs to be clean, refined, and it has an output either in the form of analytics forecasting or decisions, or output in the form of, let's say in Gen AI, it will give you an output in the form of a text, or if it is LLM text, if it's Gen AI based uh, platform, it can able to give you recommendation. Even right now using Sora, they can able to generate not only images and also videos. So in terms of manufacturing and industry 4.0 ecosystem, we have we have a product life cycle. So in sustainability connected process, you have equipments that needs to be IoT enabled. Why? Because we need to fetch the data. We need to have a data monitoring or data ecosystem real time. Real time means that what's going on right now in one of the factories anywhere, you get the visibility out of it. So equipment has to be IoT enabled, and then your process is having with many process. One can be a quality management and sustainability of manufacturing process, and then you need to have a people. So one important thing, many MNCs and GLCs is asking me one question. In terms of AI, whether it will replace us, it depends. So in that landscape of digital transformation, you can understand one thing, that at the bottom of that ecosystem, in terms of people, you have operators. So for meeting the need of digital era, you need to upskill your operators to become technicians. And then the technician needs to be upskilled to become engineers. And the engineers need to be upskilled in terms of specialized in terms of IoT, for example, data scientist, AI engineer, deep learning engineer, blockchain engineer, data engineer, cybersecurity engineer, and so on. So those process, people, and environment are basically part of your integration process. So at the core, you have IIoT layer. So in that layer, you have machines, devices, and sensors. And it is producing a structured data in the form of numbers, temperatures, RPM, vibration, and also unstructured data in the form of images and videos that has been pushed to your cloud. So you have a smart process. So you are capturing a lot of data coming from your process, from enterprise level, and also from supply chain. So that data has been stored in your data infrastructure with a proper data governance. So data governance is something which is really misunderstood in most of the organization, and it has a quality aspect of things of the ecosystem in terms of sustainability. So I think that is a different topic. But using your data governance ecosystem, you have a descriptive analytics, which is the first type of analytics, where you understand what happened in the past, diagnostic why it happens using RCA, and then predictive what can happen in the future, and prescriptive. So your predictive, so descriptive and diagnostic doesn't use AI. Your predictive does use AI with machine learning, and your prescriptive use machine learning, deep learning. So that deep learning aspect and machine learning aspect is assisting you on the application level to have a smart product life cycle management, smart design traceability from end to end, whether manufacturing, warehouse, or supply chain. You have a shop floor control in terms of transparency and visibility. You have a shorter lead time and downtime. You have a remote maintenance done by either supervisor, technician, or even machines, or you have a fault diagnostic that assists you in terms of your environment sustainable KPIs, economic sustainability KPIs, social sustainability KPIs. In short, it fulfills your ESG goals. So machine learning and deep learning are basically important part of your smart manufacturing ecosystem. So after discussing about deep learning, let's go more into Gen AI, especially how we can leverage it in industrial landscape or even beyond. So when we talk about technology stack of Gen AI, you need to have a data. That data can be text, audio, structure, images, video, or even code. So that is a definition of the core data that you need to have, and you need to have a proper, again, governance system or infrastructure that can enable the granularity in terms of veracity and also in terms of volume and also for sustainable scalability. So you ingest the data from machines or different systems, and then after that you train the model. So between ingesting and training the model, there is a process for data wrangling where you are refining your data, where you are making sure that the data is clean. All of the data format is proper. There is no empty value. They are not outliers and they are no wrong value. So once you're having surety of that, then you are going to train the model. So we don't cherry pick. Sometimes we have to go for brute force if we are exploring new area. So training different LLM or deep learning models, we then fine tune it to consider for the accuracy aspect and also performance. We if your deep learning model is having a high accuracy but bad performance, then it will affect your OPEX. So we want high accuracy with optimized performance and also resource utilization because at the end it will impact your green tech environment and also affect your capex and opex. So once the models are being tuned, then we're looking into interference and also hyperparameter modeling and then run the model. And after we run the model, we do the testing and then deployment. After the deployment is been done, we monitor whether they are performing well or not because we are getting influx of the data. So key activities we need to consider, just like Mr. Arshad mentioned, and I believe Mr. Afsal will also mention about whether your AI possible policy is responsible, your AI is having an ethics. What is your strategy and roadmap? What will be your intelligence architecture for end to end? And what is your reskilling and training capability? So, are we looking into broader prospect of having data literacy? So, as we are talking about AI, machine learning, deep learning, Gen AI, LLM, everything, that level is the final level. And the prerequisite of that final level is analytics. And prerequisite of analytics is data literacy. So data literacy needs to be across the board in an organization horizontally among all of the department and vertically, which is your executive, middle management, and top management. So the $1 million question here is very simple. How much data literacy you are having? In Industry 3.0, we are looking into IT as an enabler, doing everything for us. Now, no. Now they are collaborative. So if you would like to design an analytics dashboard, you don't need to have an IT or computer science background. You just need to have a learning ability, critical thinking, and use those tools to create your own descriptive, diagnostic, predictive, and prescriptive analytics. So you in the Industry 4.0 era, you will not be going to IT. Can you make a dashboard for me? No. You will be going to IT. Let's collaborate. I need these resources. Provide me these tools so I can able to develop those analytics. Okay. So reskilling on the data literacy, whether you're IoT engineer, cloud engineer, analytics engineer, cybersecurity engineer, DevOps engineer, whether you are architect, you require data literacy. So data literacy is quite essential. Unfortunately, IPTA and IPTS dalam Malaysia are a bit behind on that. So when we are getting intern and also full-time employment, people who are applying for the full-time, they lack that. So data literacy is not for computer science, computer engineering, and IT background people. It is basically an essential element in every faculty. Why? Because what industry revolution is data-driven revolution. So data is everywhere. The main goal is how to understand and monetize it. When we are looking into Gen AI technology stack, right? So we have application as a service. I term it as a AI as a service. AI as a service. So for that AI as a service, you have a experience layer, That is your top layer in terms of applications. At the bottom, you will always start with the cloud or on-premise. The question here is, for machine learning, you can use your laptop. You don't need a heavy-duty machine. Dual core or quad core, simple laptop will be good enough. But for Gen AI, it's a large language model. Large means it has a large sets of data that needs to be processed. So you require a server or a cloud. Now for the cloud, it's pay per use. The more services you are using, the more payment you need to make. So Google Cloud can be a one example that for the free you can able to train them. So they may be connected with your CRM or ERP, and then you need to have a cloud foundation to integrate the API. This is a bit technical. If you have some further questions, you can able to email to us. But what I wanted to mention to you is this, that there are some different type of databases that have the data that needs to be fetched by the API to be given to the artificial intelligence system. So those can be vector database, data warehouse, or data lake. Data lake or raw data warehouse or semi-refined. Vector database can have a refined data as well. You might have a different data source, IoT or other sources that can have structured or unstructured data, again, fetched by an API gateway to give into your system. And at the end, when you are doing the testing of either deep learning or machine learning or LLM system, you need to understand the quality output and check in terms of veracity, which is authenticity. You need to check whether the data which is an output or decision which has been output, is it correct? Second thing, you need to look into, is it ethical? Is it biased? So if you find something, then you need to either change the model or improve the model in this regard. So the blue areas or boxes are tools, dark blue are app, light blues are models, and then cyan is basically those which are having a data, and your dark green is your infrastructure over here. Okay, so some applications that you can find is Mid Journey. It used to be free, but not anymore. But you can able to have more Gen AI based application that use those things. So where the data is coming from? Just now in the previous session, Mr. Arshad mentioned that there was some ethical issue by one of the AI chatbots for the Democrats because it is getting the data from the website. So you need to understand Google search also have a search engine. It's also using artificial intelligence. But that AI intelligence is basically to select from millions of records to select the most appropriate one and give it on the first, second, and third entry. So that decision making is AI. So they are understanding the context. Gen AI, on the other hand, is one step further. It's fetching those data, understanding, and then also reason with you. So in terms of key touch point, I want to give an example over here. For the key touch point, for example, there's a chat GPT to for the customer having a request for a booking, online booking. So how the chat GPT and Gen AI will be working step by step. You have a customer which is end user like you and me. We have a customer log request. We said we wanted to request to change a booking. For example, I'm going overseas. I have an issue. I need to change a booking. So you also have a customer reviews coming in. We will discuss it too. So you are customer is requesting, can I change? This is my booking number. This is my name. This is my IC passport number. This is my flight detail. This is the date and time, and this is my flight number. I would like to change from this date to this day. So when the customer will enter this request, then the chat bot will be activated. After the chat bot activated, it will understand your chat using NLP, having a tokenization, taking into context, and give that input data to your Gen AI model. That Gen AI model will receive your user request, pulls the user info, pulls from where? Pulls from its database. So it has a database with a customer ID, customer history. Now, this customer ID is specific. Maybe the customer is from Malaysia. Maybe the customer is having different race, different preferences, different age group. different gender. So they are different criteria. And you have a other customer history, not only this customer, but also other customer. You have your own policy in terms of changing. For example, if you would like to change a flight 48 hours before, you need to pay 20%. If you have less than 24 hours, it may burn. So there might be a policy depending on different airlines. And then you have a booking system data verification and agent assignment. So this data will go over there, the request, and it will be pulled. The next will be model will check the policy booking policy and see if the customer can make changes or not. Like in Batik Air or AirAsia, if you're booking, there are multiple booking. One is called Flexi. Flexi can able to change. Non-Flexi cannot change. For example, they have to burn. So it will be checking that booking policy, and then the model explain the issue and give alternative option back. So let's say the alternative option is that you can change it, but there will be penalty because you are requesting less than 24 hours and you book flexi. So that will explain either customer will agree or disagree. If it disagree, it will ask and contact the agent and then also ask for the support. So the support person will able to look into whether to have a specialized person or not. In terms of customer agreed, then you proceed with a booking system and then workflow booking and check the booking system to have next available flight. Does it? And if that is available flight, whether there is an available seat. And then after it will give this system and then it will give back the instruction back to the customer. So this is non-tag based flow of your chat GPT of a booking system that is using a chatbot. So here there can be a large language model, depends. Okay, and then this thing is on the on cloud or in infrastructure. This is a very basic chatbot based application with the Gen AI. Now the data, which is LLM, depends on how big data you have. So that needs to be hosted on premise or cloud, mostly or in the cloud. So in terms of technology stack, what type of uh, how much time I have?
5 minutes, doctor.
Okay. So in terms of basically what type of technology you will be using, so you need to understand the component first before we proceed with the technology. You need to have a large data for deep learning. Machine learning, maybe a couple of 100,000 Excel row or CSV. But in terms of deep learning or Gen AI based ecosystem, you need to have a large structure or unstructured data. So you need to have a data storage. Then after you store the data, you need to do data pre-processing and feature identification. For the big data processing, we either use Databricks, but it's costly. If you want to go for open source, it will be Apache Spark. Then you need to have supervised or unsupervised machine learning models. And then after that, when you have that models, then you have to have a transition to deep learning. From that deep learning, the next step is to have an NLP or NLU. NLU is a part of NLP. Natural language processing have a part of natural language understanding and sentiment analysis. NLU will able to understand, let's say in Gen AI case, so Chat GPT, is understand about the context and also understand about the meaning. Whether you are asking in English, Malay, Chinese, French, Urdu, or someone, and then understand the sentiment analysis. This sentiment analysis is deep learning. Then you have a visual data interpretation and recognition using deep learning. And having leveraged this whole thing, you are controlling the autonomous system, which is a part and hosted on the cloud and scalable infrastructure. So cloud, we understand that it's a cloud. What is scalable infrastructure? That it will automatically have an orchestration. If there are more input user are connecting, it should not slow down. Other than the resources can expand based on the use, which can be used Kubernetes ecosystem and also containerization, which is Docker. So what I just now discussed, this is the bird's eye view or helicopter view of AI stack in terms of data management, stage one data acquisition that require data aggregation, annotation, and synthesis. data transformation and storage, which is data transformation mechanism, storage modalities, and synthetic data generation. So the all those stages depends on which cloud provider you're using. Item Microsoft Azure number one, Azure AWS number two, Google number three. So they have their own managed services. The drawback is if you use them, you have to pay. Their service additional. So you can use open source as well as cloud, have a hybrid approach. So number three is data processing and framework, and number four is data versioning because there might be different type of data. You need to version not only your AI model but also your data models. And then you have a model architecting and performance metrics in terms of selecting of the AI models, development ecosystem where you are developing, training, testing, deploying, and monitoring. So that monitoring is tracking and replicability. Tracking means whether they are performing good or require further improvement, and then evaluation metrics in this regard. So this is a landscape for the stages of AI technology stack. In terms of processing, we can use Spark. Exploration can be using Python Panda. For data processing, we can use either Databricks or we can use Snowflake if you want to have a cross-platform application. If you are stick with uh, a cloud provider, either Google or AWS, then they have their own managed services. Okay. And then in terms of distributed framework for AI, there are many. The most common one can be PyTorch for deep learning, for facial recognition, TensorFlow, and so on. And then for experiment and model, MLflow. For engineering, you can use Jupyter Notebook for the POC and so on. So this is the AI landscape in terms of your AI model development, testing, training, testing, and deployment. The Datalytica Gen AI roadmap is basically that you can able to, our humble recommendation will be phase one to understand mathematics if you haven't studied, have your learning in terms of Python programming, and have a descriptive analytics. I use Power BI, it's easy. You can use Spotfire or Tableau or any other tool that you like to have. The main thing is how you can have descriptive analytics and diagnostics. Then machine learning basics will be phase two, where you will have a data science in terms of Python library, pandas, NumPy, scikit-learn, also matplotlib, plotly, seaborn, and deep learning will be TensorFlow or Keras or PyTorch. My favorite will be PyTorch. Phase three will be on specialized knowledge in NLP, computer vision, and advanced neural network, which is deep learning. And then stage four or phase four will be generative models, which is GAN, VAE, LLM framework, then how to fine tune them and how to use large data sets. Sorry, there is a mistake, typo mistake. And phase five is basically learning from community POC4 and then having some R&D. So for the continuous improvement, because just like previous speaker, Mr. Arshad mentioned, every single year there are a lot of AI models coming into, so we need to check on that. My second last slide is on industry strategy moving forward. If you are from industry and top management, if you are someone decision maker, or if you are looking into how you can able to learn apply, first define your AI strategy. Number two, look into what our AI product strategy can able to solve your problem and have an ROI. The three is having a portfolio management in terms of value-based investment. But after all, you will be learning, you will be applying, so investment in terms of money and time. So what will be the value that you're looking into? Then what will be the architecture, technical architecture from data ingestion, data management, governance, and AI. Data ops pipeline and also AI ops pipeline. Number five will be on agile delivery because agile is iterative approach. We will never use waterfall. Agile will be the way to go if you want to minimize the risk in terms of delivery, also increase the productivity of people, and also looking into connect, communicate, and collaborate with different stakeholders. And after that, measure the value. So this is a cycle, a high level strategy. that we need to look into any AI initiative. The startups of AI, if you can able to look into for the deep learning, there are many. We are one of them. We started on AI computer vision based deep learning, where we are measuring the productivity monitoring of the people. It can be implemented in different workplace or in the industry for cybersecurity reason, also to check the productivity, and also can be used for anomaly detection, and also for OCR based application use cases, and also for facial recognition. So there are hundreds of use cases. It is a future with holds. Uh, we were predicting that the impact of creativity will be coming in 2030s onward, but no. With advent of ChatGPT, it is happening today. So we envision something will happen after 20 years, but it is happening even now. Like LLM-based models, Gen AI can able to help you to create books, stories, and so on. So things are moving fast. AI is moving fast. Humans are moving slow. We are also having one program, HRD Corp claimable, on using Python PyTorch framework. The theme will be on image manipulation and LLM models. So apart from Afsal, myself, and Hushan, we will be having Mr. Arshad also as a guest speaker in that session. The session will be happening in Penang, and it is an HRD Corp claimable. Okay. With that said, I would like to extend my sincere thanks for listening. And if you have any further questions, we can able to discuss in the Q&A session. Thank you.
Thank you, Dr. Imran, for your enlightening insight into AI deep learning application. So last but not certainly not least, we have Mr. Afsal, who served as the CTO at Robomy Berhad with over 19 years of experience in AI research and product development. Mr. Afsal has been instrumental in leading groundbreaking projects in electronics, software, and embedded systems. His expertise in brain-machine interfacing and industrial product design makes him a key figure in the AI landscape. Mr. Afsal will guide us through deep learning basic industrial application and the needs for skill development. Please welcome Mr. Afsal. Mr. Afsal, you can unmute yourself.
Okay, can you hear me?
Okay.
Okay, thank you very much, the previous speakers for introducing the key technologies in the sector. My topic will be the basics of AI. May I know how many time time I can take?
Maybe 20 minutes, Mr. Afsal. Is it okay?
So how much?
20 minutes. Yeah.
Okay, so 20
Okay.
minutes. Okay. Basically, as Halifa introduced, I have been working in this domain for last 20 years, and most of my discussions are based on my experiences. A few things before I start. Currently, I am not in my office. I have to come to Surabaya for a meeting, so I found a silent location. But if you find anything disturbing, please forgive me because I am in an open space. But if you find it difficult to listen to me, you can hear, you can let me know. Second thing, I have few slides. Basically, I use it for introducing the basics of deep learning. I know there are wide, different communities here. From different background, people from different background. So if some of you feel that is way too basics or forgive me, because again I am trying to bring in the basics of a very big topic into very limited aspects. So let me on slides. And again, if you have any questions, you can ask during the Q&A session. I hope you can see my screen. You can see my screen, right? Hello.
Yes, Ms. Afsal, you can.
So we have been a part. If you are working in the IT sector for last 20 or even 30 years, you might have seen a lot of revolutions happening in the computers. Maybe, for example, when I started working, the internet speed was few KB per second. The memory size was few MB, and also the disk size was few GB, even less than 1 GB, and also the computational power was sub 1 GHz. But now we have seen drastic development in computational capabilities, but also the same with the size of the computers. The we have the power of a supercomputer in our wrist right now. That's what I mean. The power of supercomputers of few years back. But the way that we use any computer that we have is we have the computer, we write the program. But for the long years that we have been in this evolution, there was a missing link. We know the intelligence was the missing link. So we we thought we could do anything from with the computers, but a lot of things were missing. That means the primary aim of using computers was to imitate human capabilities, but intelligence again was a missing thing. So basically, what we aim with AI itself, and more specifically with machine learning and deep learning, is to implement that kind of intelligence into uh, machines by implementing a lot of technologies. So if you see, AI is the simulation of human intelligence by software. Mostly we are implementing this artificial intelligence in AI. But during the early times, there was a huge effort into implementing AI into hardware. If you see the IBM Deep Blue and all those systems that we learned when we were studying in the universities, etc. And even those things are not even considered AI now. The trend of that time was to utilize cap power, I mean the capabilities of the hardware, the computers, to imitate human intelligence by technologies like expert systems, etc. Even technologies like those expert systems are not even considered AI nowadays. It's sometimes people call it traditional AI, but the current trend is deep learning. Current trend is machine learning. So in machine learning, just like what we do with this AlphaGo, it's not like we are utilizing the computational capability of any hardware to work faster than human, but we are making the system learn from uh, humans, learn from real life events. So this is the difference between these two systems, AlphaGo and Deep Blue. So AlphaGo, sometimes people say this is a beginning of general AI, because this is that was a point when deep learning became very prominent in such a way that people uh, people started thinking about even losing jobs because of AI and all those things. Even before, even in those days where AI was being discussed a lot, people never thought that AI is not going to take their jobs, etc. So you can see the historic milestones. I'm not going to discuss more, but you can see that uh, the revolution in AI happened when deep learning became a prominent technology. Deep learning, as the previous speakers mentioned, is a subset of machine learning, but it's so advanced in such a way that it can replace everything that is done by other uh, machine learning technologies. So let me go through some impact of AI, because my slides I want to mix up the technology as well as implementation without going into too many topics. But you can see it's changing our workplace. We are seeing more machines in our workplace. For example, if previously I took 15 to 30 days to come out with an architecture to build a minimum viable product at POC, now I take 2 to 3 days to build a minimum viable product. And that's something I am using a lot of technologies like Copilot, etc., code generation engines, etc., to develop uh, these systems. So the client expectations are also changing. Previously, if the client asks if he could code a product development for 8 months or 12 months, for example, now the clients are expecting the product to be developed in, let's say, 3 months or less than that. So the client expectations are changing. That means we are forced to use these technologies. It's not a way to change jobs, it's revolutionizing our jobs. But as a company, we are also forced to change our workplace. So that we see a lot of these AI tools in our workplace. AI in healthcare is a big domain. We are also working in a lot of healthcare related AI topics. AI in finance, fraud detection is one area that we are working. Chatbots is another area. So food quality analysis, we are using image analysis for analyzing quality of food. Food quality analysis is one area, but we are also working on other areas like textile, quality analysis, etc. All those technologies utilize AI inside. So these are some of the areas that we use, route optimization, and we are utilizing this to provide support to companies like delivery companies, etc., to optimize their route to see um, where to deliver the item and in a faster way uh, by using lesser oil, etc. One of the areas that AI is used most in industries in industrial application is predictive modeling. In this example, you can see a factory floor was being destroyed in less than 1 minute because of a hydraulic leaking. So it's like real-time systems will fail here. If you are going to detect that the valve is going to break in real time, then you are you are destroying the entire industry. So in this case, we are able to predict what is going to happen. So predictive modeling will come into picture. This is one of the area that we are working, anomaly detection in pipelines. So that means we can detect anomalies and we can predict earlier. Small businesses also use AI. So it may be wonder to see we are working with small businesses like food trucks, etc., to predict, for example, how much nasi lemak should I make today, where to park my truck, etc. Like what kind of items should I stock, what kind of items that I have to put in the front door, etc. So not only big industries, AI is going to be implemented inside even small industries. Even in the personal life, we are using AI a lot for detecting routes, for detecting climates, friend suggestions, self-driving cars, etc. So that's where the discussion comes about AI and upskilling. So people ask whether AI is going to kill my jobs. So this is one of the questions that we get from most of the discussions, whether we are discussing the AI with university professors or we are discussing AI with students, school students, they have the same question. Will AI kill my job? Am I going to be employed in the future, or is job going to be uh, my job going to be vanished? So That's a big question. I'm not going to answer now. But what I'm connecting to one of my earlier slides, there we will see a lot of shift in the way that we work because of technologies like deep learning. A lot of AI tools will be in our picture. So that forces us to upskill. If you are not going to upskill, then it's sure that your job is going to be uh, in trouble. So generally, machine learning is where you learn from some data, and rather than explicitly programming, you learn from data, and the core methodology where the system works is developed by the system itself. The model, we call it an AI model. The model which does the core part of any application is developed by the system itself. So just comparing, previously we had the Elisa, the chatbot. Now we don't consider that as an AI. It was developed by a rule-based system. And the current system, LLM, ChatGPT, and all are trained by everything in the internet. We call it internet scale data. So anything that can be, we call it tokenized. It's a text. We use it for training. And we have the discussion of discriminative AI and generative AI in the deep learning space. The deep learning technologies became complete when we have the developments in generative AI. This happened in last 3 to 4 years. Personally, I have been training generative AI for last 4 to 5 years using generative adversarial networks, etc. But the most important developments happened in last 2 to 3 years. So instead AI combining, we trained the machine from experience. So we previously, before 10 to 15 years, when we were working with computer graphics programs, we use legacy algorithms. So if we had a symbol, uh, shapes, etc., we were able to detect using legacy algorithms. But if you have very complex images, even I got a lot of such requests from the clients, but we couldn't do those days, like 15 years back, etc., like detecting humans, detecting other things, counting animals, etc. So now we are able to train a deep learning model with hundreds and thousands and millions of images, and we are able to make the model, the output of the training process, detect anything, any objects. And with the development in generative AI, we are able to generate contents as well. So it's going to be a very interesting area, but it's going to be an area where we need to focus. Where I'm just now I mentioned about upskilling, and AI is a very broad domain, and you have to focus on the areas that you are going to upskill. I just mentioned some of the projects that we mentioned we did before. Sometimes like we need to count circular objects, etc. We we could do by the traditional methods, but when we started working on healthcare AI, etc., where we want to detect tumors, and in the COVID-19 period, we worked to detect COVID-19 from chest X-rays, etc. The traditional methods will fail. That we need to use deep learning. So these are some of the areas that we are using deep learning to even to detect images, I mean objects from very complex scenarios uh, by using data. We we use data to train the machine, train the algorithm, and deploy the model in a cloud environment using uh, ML ops techniques. The the DevOps and all those agile and all those things are done in order to come out with a complete product. Generally, machine learning is to utilize the data uh, to make a prediction, or we do the data exploration, or, or I mean decision making, etc. One of the areas where we we could use is predictive maintenance of vehicles, predictive maintenance of industry equipment, and all those things that we 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 make we develop the AI model from historical data, historical breakdown data, historical operational data, so that we can predict the failure of a machine. We can predict the failure of a vehicle even before it happens, even days or hours before it happens. So generally, machine learning can be divided into supervised, unsupervised, and reinforcement. But there are combination. The reason for the success of ChatGPT and other LLMs, especially ChatGPT, the OpenAI came out with the idea first. They used a combination, a very nice combination of these three learning methodologies in such a way that uh, the result was overwhelming. That means we saw something like a human like performance. So another areas that we are working on, as I mentioned, fraud detection, where we could learn from huge volumes of data. Uh, I mean, historical transactional data, and we could detect uh, patterns of frauds. So this is just an, I mean, a slide to give some ideas. But as I mentioned, currently we can use a combination of any of these learning methodologies. But there are a lot other applications as well. I'm not going to mention all here. So generally, where deep learning comes in is in many of the modern machine learning applications, extracting the feature and training the machine learning model is not that easy. So we need something like a brain-like system. So deep learning is actually we can call it like a mathematical modeling of our brain, where we can implement an artificial neural network to imitate the brain and can learn from huge volume of data. And not only it can learn from data, it can extract the patterns directly with other machine learning algorithms, the traditional machine learning algorithms, and not the traditional AI. With other machine learning algorithms, we need to extract the features and train the model. But in deep learning, in artificial neural networks, we don't need to extract the features. We can the model itself can extract the feature. There is a lot to explain here, but the time is limited. There are different kinds of neural networks for different applications. The LLM, the successful LLM is one of the, I mean, is because of the result of a very advanced neural network called transformer network. And if you see the image generation like DALI, Stable Diffusion, and all, they work based on generative image technologies like diffusion, explicit models, generative adversarial networks, etc. We use convolutional neural networks for image-based applications, neural networks for uh, basically neural networks for the predecessors of the transformers. They were able to, they were being used for chat GPTs, etc. So, I mean, concluding, machine learning versus deep learning. Deep learning is a brain-like system. It can extract the feature from the data. We don't need to explicitly extract the features. Data can be anything, and a combination, uh, it can be anything that is digitized. So one of the areas that we work, we worked this together with Intel. So Arshad is from Intel. Actually, it's from MIDA, Malaysian Industry Development Authority. They work with together with Intel, and this Intel is the GPU-based industrial PC and other things like FPGAs for complex deep learning applications were uh, given free of cost for us to develop some sample projects. So we developed a project to automate defect detection in electronics assemblies. Large language models, now it's the era of generative AI. Large language, we have the large language models, the Gen AI tools, I mean, ChatGPT, Gemini, Mistral, and all those tools, open source, as well as proprietary tools. So it's getting a, a big, I mean, a big reception in our workplace. But in order to use these LLMs in industrial applications, we have to fine tune. We have to fine tune. So in order to fine tune, we use a technology called uh, RAG. RAG is retrieval augmented generation. So in RAG, we use extra additional knowledge sources. So in industrial applications is confined to some particular environment. So LLMs are huge systems. So if you use LLMs are also prone to a lot of issues like hallucinations and other issues because they are trained from internet scale data that also contains a lot of garbage. So in order to use LLMs or these techniques for industrial usages, we need to utilize a technology called RAG. And the examples are generative image and other tools. In many cases, I work with these tools directly to the base level, so I'm not going to explain it, but it's a very big domain. It's interesting as well, and also going to dominate other LLMs. I mean, we are coming to see multimodal models, multimodal generative AI models that can deal with images, text, videos, and other kind of data as well. So generative AI training generative AI is a very difficult thing. That's why we mentioned the RAG, the retrieval augmented generation, because we cannot fine tune a Gen AI for use case. So training, but in cases we have to retrain a generative AI, especially when we work with open source LLMs. We have some clients asking to fine tune generative AI for their particular use cases. So other the image generation tools they work with, they work also in the same way, but they are trained in such a way to generate images pixel by pixel. It's not generated by copying from other sources. No, they are generated pixel by pixel because they are trained to do so. And like, for example, rather than just training with an object, etc., they they are trained with captioning. So these images are trained with captions, so that whenever we give a caption, the model will be able to generate the image. It's more than that, but it's a simple way to detect. So there are a lot of AI tools that, and the number of tools are also increasing that can increase your productivity as well. A lot of tools are being used in industries as well. But one of the areas, one of my final words regarding this is, like, you have to be very careful in using the recent tools like generative AI, etc., for industrial applications. So because there is a trend happening out there, but this is also an evolving domain. There are a lot of areas where we need to mitigate the risk. Generative AI is still in the nascent stage. You can use it if you are an expert in the domain. I mean, if you are an expert in chemistry, you can use generative AI for some chemical related things. Otherwise, if you are not an expert in chemistry and you are trying to come out with a new chemical experiment, then you are going to be in trouble. So this is just a simple example that can be applied to any use cases. So finally, sorry for the environment. I am here in Putrajaya, near minister's office. So I have a meeting with minister, and I came out to find out some area. But this is it's a people. I mean, a lot of people moving there. Sorry for the trouble. So that's all from my side, and we can move on to the Q&A session. Thank you very much.
Thank you, Mr. Afsal, for your insightful exploration of keep learning basic and industrial application. So before we start with the Q&A, as mentioned by Dr. Imran just now, at the end of this month, at the end of this month, we will be conducting a program called AI Deep Learning in Industry 4.0. So you can scan the QR code for registration, and I will put the details of this program in the comment section. Okay, so we will invite our speakers for the Q&A sessions. Your queries and thought are crucial as we collectively explore the frontiers of AI and deep learning. You can unmute yourself or type your queries in the chat sections. But before that, I would like to ask the speakers, um, in your opinion, what are the primary challenges organizations encounter with implementing AI and deep learning solution, and what strategies can be employed to effectively address these challenges based on your experience? Any speakers can share your thought and opinion on that.
Yeah, there are, sorry, can I take the question?
Yeah, Mr. Afsal.
There are there are two challenges mainly. One of the challenges when we deal with clients is the availability of data. For example, they have a requirement and we have the solution to solve their problem, but in many cases they don't have the data available. I mean, uh, they were not keen, they were not aware to uh, keep the data. I mean, in a proper way so that we could use the technology. And coming to the skilled workforce, one another area that we face is the non-availability of skilled workforce in deep learning sector. Many times we have projects, but we find it difficult to get skilled workforce. So that also is one of the challenges that personally I face in my in my area.
Thank you, Mr. Afsal, for your insightful opinion. So I will open the floor to the participant to ask questions. If there is no question from the participants, as we draw to close, I want to extend a heartfelt thank you to our esteemed speakers, Dr. Imran, Mr. Afsal, and Mr. Arshad for their invaluable contribution. Your insight and have truly enriched our understanding of AI and deep learning in industrial application. Before we conclude, I encourage all participants to stay tuned for our upcoming webinar, which we will next webinar for next month, and we will be announcing it on LinkedIn, Facebook, and our social media channels. Keep an eye out for another exciting exploration into cutting-edge technologies and industry insight. Before we conclude, we we need to take a picture for group photos. Can you guys open your camera?
Thank you very much.
I have attached the feedback form for you to fill up the form so that we can improve our next webinar. Thank you, everyone.